All right, guys, so I've had a few requests to go over some of the test review questions. If you looked today, I posted a quiz on trig functions. Just it was like 4 or 5 kind of quick questions there. Just trying to honestly just play around with Google Classroom a little bit today, just in case we do have to give you guys some assignments. So when you get the chance, check that out. The due date for that is, I believe I set it for either 1 or 5 p.m. on Friday. So just try to get it done by then. Honestly, it's out of 25 points. I'm not grading it solely on accuracy. I'm honestly just seeing who is logging on, who is taking the time out of their day to try to help themselves stay on track, because hopefully we do get back to doing some stuff here in the next month or so. So I'm going to walk through. I'm going to split this up. These first 6 questions on your test review are kind of long, so I'm just going to make a video on these first 6, and then if people want to see some more of these questions later on, we can do that as well. So first question, we are just going to label these important information like the amplitude, the period, PS is phase shift, and VS is vertical shift, and then we're going to graph it. Some of these, like question number 4, that's a significant amount of work. Might need like a separate sheet of paper if you're going through and doing this. I was just doing it on a scratch sheet of paper just to check my work, and I'm probably going to need to do the same again unless I can write nice and small for you guys. Okay, so getting right into question number 1, starts off kind of basic here. That first number that we always see is our amplitude, and if it is negative, that just means that it's reflected over the x-axis. So when you're answering the question amplitude, it's still a 2. That just means from the midline, you're going to go up 2 units, and then from the midline, you're going to go down 2 units. That's how you get the maximum and minimum values for that sine wave in this case. The period is always, that formula for the period, I'm going to write right up top here, is always 2 pi over b. So if you haven't done the quiz yet, this is actually one of the questions. So when you're finding this, if you remember, b is always that number, that constant, that coefficient of the x value. It's squeezed in between sine and x. So for this example, the period is going to be 2 pi over 7, because that's what b is, so 2 pi over 7. And that doesn't reduce at all, so I can leave it as 2 pi over 7. A phase shift is if you were adding or subtracting a number to this x term inside of parentheses. There is none, so I can just do not applicable. And then the vertical shift, that would be the k value if there was adding or subtracting on the outside there. Once again, there is no phase shift, so not applicable there as well. Okay, so before we get graphing this, I want to go through, and that one question that I always seem to leave off are those increments. Oh, almost spelled that wrong. Increments. The way we find the increments is we always take the period, which is 2 pi over 7, and we multiply that by 1/4, right? This is going to tell us what we need to go up by. If you look at the directions, those are those 5 key points, right? Okay, if we do this, we get 2 pi over 28, which is pi over 14. Pi over 14. Yes, that is correct. I feel like my math is a little rusty. I'm a little rusty right now. Okay, so what this means is when you're going up on your x-axis, we were just adding a pi over 14. And if you remember, we were a little nice to you guys, and we did not make you necessarily have to reduce those values on the x-axis, because that just becomes a little tedious. Okay, so I'm going to draw in my x and y axes here. Try to make sure your midline is directly in the middle of your highest and lowest points. Since there was no vertical shift, I'm labeling my y-axis right now. My midline is starting at a 0. And since my amplitude was 2, I just know that my max height is a 2, and my minimum height is a -2. All right, since there is no phase shift, we're also starting at a 0, so my origin is technically 0, 0 in this case, no vertical or horizontal shift. And I am going up by pi over 14, so this is 0. My first notch is going to be a pi over 14, and then I'm just adding an additional pi over 14 every single time. So this will be 2 pi over 14, 3 pi over 14, and then lastly we have 4 pi over 14. So I have my 1, 2, 3, 4, 5 key points. And then always double check. So from my starting point, which was at my origin, to my ending point, is 4 pi over 14, which is also, if I reduce that, 2 pi over 7, which is the length of my period. So the period should always match the distance that you traveled over those 5 key points. Just be careful, because sometimes you're not starting at 0, 0. So it's not always going to end whatever the period is. All right, last thing I want to do is I want to plot my points. Since I know it's a sine function, sine starts at the midline, and then since my value is a negative, I know it's reflected over the x-axis, so my first move is down. So I go down, back up to the midline, all the way up to my top amplitude of 2, and then back down to the midline, and then I can draw in my sine wave. There we go, all done. All right, so remember, sine starts at the midline. So I had a good question earlier today. Somebody asked me, based on my starting point, how do I know if it's a sine or a cosine function? Sine will always start at the midline. Cosine will always start at one of the 2 amplitudes. If it's a positive cosine, it will start at the top. If it was a negative cosine, it would start at the negative amplitude. Okay, next question. Moving right along here. I wrote nice and pretty for you there. Okay, now it says very similar question here, except for we do have one extra little curveball here, and that is we do actually have a phase shift. There is something happening, right? I have a left and right movement because I have a term that is added to my x value inside of parentheses. If this 3 pi over 5 was on the outside of the parentheses, I know that would be a vertical shift, but it's not. All right, amplitude, once again, always that first number you see, 1/4. The period is always going to be 2 pi over b. B in this case is a 1, right? There's no number that's in between the cosine and the x variable, so it is just going to be 2 pi. My phase shift, this is the confusing one. If you remember, it is always the opposite. So a positive 3 pi over 5 technically goes 3 pi over 5 to the left, right? It is a left shift, and there is no vertical shift, so not applicable. All right, last thing we want to do, as we always want to, is we want to find those increments before you start doing anything. Those increments, you take the period, which in this case is 2 pi. I'm going to write it as 2 pi over 1. Multiply it by 1/4. I get a 2 pi over 4, which is pi over 2. That's that most common one that we see a lot. Okay, so now when I graph this, exact same thing, like nothing changes. I'm going to draw in my x and y coordinates there, or my axes, excuse me. My midline, once again, if I'm looking at my y-axis, is starting at 0. There was no vertical shift. My amplitude is 1/4, so I'm going to go up to 1/4. I'm going to go down to a negative 1/4. And the only big change here is now I have a phase shift. So I'm not starting at 0, 0 like I did over in this example. This first point is going to be a negative 3 pi over 5. All right, sorry, there's not really a good place to label this. Maybe I should put it on this side, but negative 3 pi over 5, and then I still need to get my 1, 2, 3, 4, 5 other values. All right, since I know my increment is pi over 2, I just take this negative 3 pi over 5 and I add pi over 2. And then I add a pi over 2, and then I add a pi over 2. I'm just doing that 4 times. All right, hardest part about this is there is not a common denominator, so I cannot just add a negative 3 pi over 5 plus a pi over 2. I need my 2 denominators to be exactly the same. All right, easiest way to do this, you can find the least common multiple, the smallest value that both of these numbers can go into, which is actually a 10. So we'll make both of these denominators a 10. All right, and then in order to get from 5 to 10, I multiplied by 2, so I need to multiply the top by 2 as well. In order to get from 2 to 10, I multiplied by 5, so I got to multiply the top by 5 as well. Once you finally have common denominators, you can just add your numerator straight across. So a negative 6 plus 5 is a negative 1 pi over 10. So this value is a negative pi over 10. The good news is, since you don't have to worry about reducing this x-axis, I can now just take this and add 5 pi over 10, right? So that'll give me a 4 pi over 10, right? Negative 1 plus 5 is 4, and then add another 5 pi over 10. I get 9 pi over 10. And then lastly, add one more 5 pi over 10, which is what, 14 pi over 10. All right, so every single time you went up, you added a 5 pi over 10, which is the same thing as a pi over 2. We just got common denominators. If you're super worried and curious to whether or not you did this correctly, we can always double check our period here. I can go through and I can take 14 pi over 10 and I can subtract a negative 3 pi over 5, and that should give me 2 pi. So this is kind of like a little sidebar over here, just to check to make sure that your x-axis is a full 2 period. We're going to take 14 pi over 10, and I'm going to subtract a negative 3 pi over 5. So first thing I want to clean up, subtracting a negative means I'm adding. And then lastly, I want to make sure I have common denominators. I can multiply my second fraction over here by 2 to get 6 pi over 10. Sorry, I'm writing kind of strangely. And I get 20 pi over 10, which is the same thing as 2 pi. So I know my x-axis is correct because I did travel that full 2 pi. Guys, the hardest part about this is honestly just all this fraction mess. But hopefully you guys are getting pretty decent at finding small common denominators and adding or subtracting relatively small fractions. You just got to be perseverant through it. All right, last part. It is a cosine function, so I know I'm not starting at the midline. And since it's a positive cosine function, I'm starting at the positive amplitude. So I start up top here, come down to the midline, go down to the bottom, back up to the midline, back up to the top. Kind of looks like a parabola, but you guys know it's more rounded than that at the top. It doesn't go up forever like a parabola. It's a sine wave, so it kind of has that asymptote at the top and the bottom. All right, second example done. Let's go through, let's do examples numbers 4 and 6. In my opinion, those are more difficult. If you guys still have problems with like numbers 3 and 5, I can post a separate video. I just don't want this video being like 40 minutes long. Okay, so example number 4, amplitude, we have a 2. It's a sine wave. The period is always 2 pi over b. In this case, I'm going to write it down here, 2 pi over b. B in this case is a 6, right? Remember, b is always that number that is attached to x. And if I reduce that, I get pi over 3. So my period is pi over 3. My phase shift, this is the difficult part. You cannot do the phase shift if there is a b value inside parentheses. So I'm going to erase this to give myself a little bit of space down here. But what I'm going to have to do is I'm going to have to take my sine function up here, and I've got to undistribute this 6. I got to factor out a 6. So I get y equals 2 sine. I'm bringing the 6 on the outside of the parentheses. So if you pull a 6 away from a 6x, you're just left with x. And then the subtraction sign is going to remain right there, so I don't want to worry about that. I'm going to write it right there right now. And I have to take pi over 4 and divide it by 6. So I'm taking pi over 4, and I'm dividing that by 6. To make this a little bit easier, instead of dividing, I can multiply by 1/6, and I get pi over 24. So if you take a pi over 4 and you divide it by 6, you get pi over 24. This becomes a pi over 24, and then we still have this minus 2 chilling on the outside there. So this is now my new function that I'm looking at. So I kind of don't want to look anymore at this up here. My phase shift, I know is going to go pi over 24 to the right because that didn't look right. It is a negative, so I know it's going in the positive direction on my x-axis, and my vertical shift is down 2 because I see a negative 2 as the k-value. This is like the worst case scenario. You're never going to see another example any more difficult than this. It has everything except for, I guess, a reflection, but it has a b value on the inside of the parentheses that we had to undistribute. It has a phase shift, it has a vertical shift, so it has kind of all the components here. All right, now let's get down to, actually before I do that, let's find our increments. We take that period, which is pi over 3, and we are multiplying that by 1/4, and we get a pi over 12. That are the increments. That is what I'm going to be going up by every time on my x-axis. All right, sorry, I'm trying to cram this into this little tiny space over here. So I always label my y-axis first. Remember, the k value turns into your midline, so this one actually has a vertical shift. We're starting at a midline of a -2. Since my amplitude is a +2, which it's always positive, I go up to 0 and I go down to -4, right? I'm just adding 2 to the midline and then I'm subtracting 2 to the midline. And then I know that this value is going to be, what is my starting point? I have pi over 24. So this is starting as a positive pi over 24. And now I need to find those 4 more points. All I have to do is take my starting x value and add my increments. As it always is, it's difficult because they are not common denominators. The good news is it's pretty easy to get 12 to be a denominator of a 24. So I'm going to take pi over 24 and I'm going to add pi over 12. Common denominator, I can just multiply both my numerator and denominator by 2. So I'm going to get, put a little arrow here, pi over 24 plus 2 pi over 24. And we know that equals 3 pi over 24, right? Common denominator, I can just add my numerators. So this is 3 pi over 24. And then now every time I jump up one notch, instead of adding pi over 12, I'm going to add 2 pi over 24. I want them to be common denominators. So I get 5 pi over 24. I get 7 pi over 24. And I get 9 pi over 24. If you're super worried and have no clue if you've done this correctly, you can always take your furthest x value, 9 pi over 24, and subtract pi over 24, your first value. 9 pi over 24 minus pi over 24, and we get 8 pi over 24. If you reduce this, you get pi over 3, which is the length of the period. So I know I did this correctly because I've traveled pi over 3 units. All right, last part, just got to plot all my points. I have a sine function. Sine starts at the midline, and it's a positive, right? It is not reflected, so I go up first, back down to the midline, all the way back down to the bottom, back up to the midline, and then I draw my nice curve in, and I am done. All right, guys, it is not going to get any more difficult than question number 4. All right, last question of the day. Excuse me. We'll do question number 6. All right, question number 6. Very similar to this question. I would say it's a little bit easier because my numbers are smaller. I also have no vertical shift, so my midline is going to be at 0. So let's go through and jot this down. So we have a positive 2/3 is my amplitude. The period is always going to be 2 pi. I'm trying to figure out where to write. 2 pi over b. In this case, it's 2 pi over 2. Remember, b is always that number that's attached to the x, which that gives me pi. Let me draw a little line here so I can separate my numbers. All right, so I get the 2's cancel out. I'm just left with pi. So the period is just pi. The phase shift, we went, I got a undistributed 2. If there was no 2 here, I could just say it was pi over 2 to the right. Excuse me. But there is a 2 there, so I can't do that. Got to undistribute first. 2/3 sine, pull the 2 out. The x goes there. It still stays as a subtraction sign. I'm now taking pi over 2 and dividing that by 2, which I can just multiply by the reciprocal to get pi over 4. A lot of you guys can do that right in your head, but if not, I always show the math, so doing that's perfectly fine. All right, phase shift, we have pi over 4 to the right because it's a negative on the inside. It's always the opposite. And the vertical shift, there is no vertical shift. There's no k value in this problem. All right, coming through here, gonna graph this. Since there was no k value, my midline is at a 0. My amplitude is 2/3, and I go down 2/3 as well. I do have a phase shift of pi over 4. It's to the right, so it's a positive pi over 4. 1, 2, 3, miss a little more space, 4. Got to go through and find those increments, which is always the period, pi over 1 times 1/4, which is just pi over 4. So this one's way easier than the last one because I'm going up by pi over 4. And I started at a pi over 4. I already have common denominators. So this is just going to be 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. 5 minus 1 is 4. 4 pi over 4 is pi. So I know I've traveled the correct amount of distance. If you feel super ambitious and you want to say that this is pi over 2 and this is pi, by all means you can do it. I'm not going to stop you. You won't lose points if you leave it like I just did. I'm just feeling a little lazy right now, and it's perfectly okay if you are too. All right, last part, plotting my points. It's a sine wave. Sine starts at the midline, and it's a positive, so I know I'm going up first. And then back down to the midline, all the way back down, and then back up to the midline. And draw your nice sine wave in, and then we are done. All right, guys, please email me if you have any questions about this review. I'll gladly post another video with the other examples. We've already done a couple of these. We did the ones where you actually have to write the function of the graph. I have not posted a video of us going through any of the word problems, but we did like 5 word problems yesterday. So if you want to see these as well, I can do that. You just got to email me. All right. The students who are emailing me, I really appreciate it. You're really advocating for yourself. But guys, continue the good work, and I hope to see you soon. Bye.